Hey guys, this is Carrie, and this is lesson 6 from Unit 9, and in this lesson we're going to be talking about something called the DNS system for the internet, which will be our last piece for how the internet works, and then we're also going to be talking a little bit about malicious use of computers. Now this part right here is super important for you to start thinking about, because when you're doing your explore task, you're going to be picking a computational device. And we talked a bit about that in lesson 1. A computational device is a device that takes input, processes data, and then outputs something. So maybe it takes in GPS data from your location. From that GPS data, it creates a map of the route that you walked, and then it outputs that map to you as an image that you can see on your screen. That's just one example. But in particular, one of the things you're going to be required to do is think, what are the risks of how the device stores data? How could the device be taken advantage of through a malicious use of computers? And malicious in this context means kind of like nefarious or bad. The image that you might start getting in your head is hacking and some of that stuff. All right, so without further ado, let's start with our do now. So hopefully you gave this question a shot on your own, but let's take a look at it now. When a device is connected to the internet, it is assigned, wow, we're starting off strong today, it is assigned an IP address. So every single device, once you turn on the Wi-Fi on your phone or open up your laptop, it logs onto the internet. And this is supposed to be a phone. And when it logs onto the internet, you may think of this as like Carrie's phone. But the internet is not going to be very helpful. So instead what happens is the internet gives it an address, which is called its IP address, and we've got a couple of examples of those. So here in problem A, we have the old system of IP addresses was developed in 1973 and called IPv4 for version 4. It contains 4 numbers between 0 and 255 separated by periods. For example, something like that. So an important question here is how many possible IP addresses can you make with this format? So the first number is between 0 and 255, which means that there are 256 possible numbers that could go there. In the second number, we have the same 256 possibilities, any number from 0 to 255. 256 for the third and 256 for the fourth. And now this is a huge number. 256 to the fourth is 4.3 billion, I believe. So let me just count that out correctly. Yeah, 4.3 billion possible addresses. And so before we address that, I think it's just important to remind ourselves one time why this number 256 is appearing again. We've seen this number in colors. We've seen this number with ASCII, where we had 256 combinations. The reason why each of these are 256 possibilities, or 0 to 255, is we use 1 byte of data for each of these. So we actually use 4 bytes, which is 32 ones or zeros that make up your computer's IP address. All right, so getting to the punchline here, 4.3 billion is a big number relative to the number of books I have on my shelf or things like that. But it's not a very big number when you think about the human population of the world. There are 7 billion people in the world. So we have an issue here. The internet needs to be rebuilt, basically, in order so that we can have 7 billion at least, right? Most of us have more than one device, maybe a smartwatch, a smartphone, a computer, an iPad. And so we need maybe like hundreds of billions or billions of possible IP addresses so that we can have all of these devices on the internet. All right, so the new system of IP addresses is slowly being integrated, and there's a small chance that when you all log on today, if you search on Google for my IP, you might have an IP address that looks very different from this. It would look something like AG13.24B7. And there are like 8 of these groups. 1, 2, 3, 4, 5, 6, 7, 8. So what I would say is actually, even though it looks like it has A's and G's in it, these are actually all numbers. They're in a different form called hexadecimal numbers that we're not going to have time to talk about this year. But if you're curious, you can do some more research on hexadecimal numbers. And these actually also come up in colors as well. So the way that this is created is using 16 bytes of data. So remember that each byte, so 16 bytes, each byte has, that's the same thing we use for the colors, it's the same thing we used here. Each byte has 256 choices. So we're going to have 256 choices for each byte. And that's going to take me a really long time to write out. So maybe we should do 256 times itself 16 times because we had 16 bytes. So if we put that in our calculator, 256 to the 16th power, that gives us 3.4 times 10 to the 34th. And I tried to write this out last time. I think I might have missed a zero, but it's 340 undecillion possible addresses. And if you watched the video that I included in the assignment last time, you saw that that was enough for every grain of sand on Earth to have its own IP address. So this will be a system that once we update the internet, will not need further updating for a very long time. All right, so here we go. The numbers in an IP address are assigned randomly to each device that logs onto the internet. So the key word here is randomly. It says true or false. This is actually false. There is some structure in the IP addresses. The first number has to deal with the region or like the country where you're logging on. This might be the subnetwork. This might be like the subnetwork, and this might be the device number on that network. So there is an order to these things, and that's called a hierarchical approach to it because it's descending in specificity, so it becomes increasingly specific as you descend down to the right, as you read these numbers to the right. All right, so we're continuing with the strong grammar here. So the program I used to write these doesn't do spell check because it's a coding program. So all of those spelling mistakes that you guys have had throughout the year that mess up your coding, I guess I'm a victim to those as well. But here we go. Introduction to malicious use of computers. All right. So malicious use of computers encompasses a wide variety of things. It encompasses hacking, viruses, identity theft, a whole bunch of things. Basically, it's bad uses of computers. And if you're really interested in the subject, I think the best resource that I can give you for malicious use of computers is there's a podcast that I really enjoy called The Darknet Diaries. And if you want to keep learning about more hacking stories, and this is an interest of yours, I would definitely check out this podcast because what they do is they go into a big famous hack in each episode, and they discuss kind of like what actually happened in that hack, and it's super interesting. In particular today, we're going to be looking at a couple of specific kinds of hacks, or a couple of kinds of malicious uses of computers. So the first one that we're going to look at is a phishing attack. We're also going to look at a type of attack called a DNS spoofing attack. I just want to make sure we get the right order. We're also going to look at an attack called a DDoS attack, which you may have heard of. And then we have a couple more interesting attacks to look at later on. In particular, we're going to be looking at something called a ransomware attack. And I think these are all really interesting to learn about because these are things that we deal with on a daily basis. All of us have received phishing emails. A lot of us have received DNS spoofing phone calls. Many websites that we've tried to access before, like sometimes you'll go to a website and it turns out that website is completely shut down because of a DDoS attack. And a ransomware attack is a particularly dangerous attack that I think you could be susceptible to. There's one more general thing that we should talk about before we get into the specifics of these attacks, which is most attacks on the internet, most cyber attacks, are successful due to a mix of software and human errors. So what you'll see is that software is designed to be very secure. There are people whose job basically it is to create secure programs, to test the programs and try to find hacks and then fix them. It's actually a really cool job in computer science where basically you get to pretend to be a hacker and hack some software so that the real hackers can't hack it. And then you find a way to fix all the hacks. But what is really hard to account for in cyber attacks is that people make mistakes, human errors. People may click a link that actually causes a virus to be downloaded, and if they hadn't clicked that link, there was no way the virus could have gotten onto the computer. So human errors are actually a big problem when it comes to cybersecurity. All right, so the first example that we're going to talk about is something called a phishing attack. So a phishing attack is... Are we really going to talk about this one first? I think I talk about this one later. I wanted to talk about a DDoS attack. So let's change this one. This one's going to be DDoS. And then later we'll talk about phishing. Wow. All right. So what is a DDoS attack? So DDoS is an acronym, and it stands for a distributed denial of service attack. And in order to understand this, it's helpful to revisit our picture of the internet. So we had our device logging onto the internet. Let's say we want to go to google.com. We send our HTTP GET request. That GET request gets sent onto the internet, and it goes through a variety of different routers. And we talked a little bit about some of the wiring last time, right? How this was actually radio waves, the wireless. And then when it hit the router, it became copper wires. And then later it might be connected by fiber optic cables. But it basically goes into this very robust, redundant, fault-tolerant network that has many different paths through it. But the goal, of course, is to reach a server here that would be the google.com server. And this is a computer. Nobody's sitting at this computer. It's just a computer that works on its own. And it basically listens for these requests. So when our request goes into the internet and through this network of routers, it eventually reaches Google. And then Google's like, hey, oh yeah, google.com, yeah, I'll send you the HTML code for that. And it sends back the HTML code to our computer. And then all of a sudden on our browser, we get Google appearing. Now, the way a DDoS attack works is Google's server may be able to respond to millions of requests for Google's site every second. So many people are using Google all the time. This computer is working really hard and just sending back, hey, here's Google. Okay, you want to do a search? Here's that search. And that computer is doing a ton of work. But if you can actually take over a bunch of computers, you can, or not take over a bunch of computers, if you can simultaneously ask Google, not millions of times, but billions of times to send you this HTTP request, the server can become overwhelmed with requests and then just shut down completely. So in a DDoS attack, the server becomes overwhelmed. The server becomes, overwhelmed by billions of requests and shuts down. That's not the word shuts down. And sometimes you can accidentally DDoS a website. This happens on Reddit all the time. So sometimes a website will be posted on Reddit, and then everyone on Reddit goes to that site, and the next time you try to go to the site, nothing happens because the website got so much traffic that the server was overwhelmed and couldn't handle it. This is actually a really dangerous type of attack. You could imagine that if you owned a restaurant, maybe, and I also owned a restaurant, and we were competing for business, it might be very powerful if I was able to shut down your website so that everyone who wanted to order online had to order from my website. So DDoS attacks can basically cause websites to have to shut down, and that's a pretty powerful thing to do. All right, so continuing on, we're going to talk about a new system, and then we're going to see how that system gets exploited. So this one's called the DNS system. So we've talked a little bit already. Okay, when our computer or iPhone or whatever we're talking about here gets connected to the internet, I may think of it as Carrie's computer. And it goes through that network, right? And eventually it may reach a server And we've been thinking about that server as Google server, or whatever server I was trying to connect to. Now, there's a bit of a problem here, which is, how do we actually connect these things? And so we learned in the last class that my computer actually gets a unique address on the internet, which is its location. So that would be something like, I don't know, I'm just making this number up. I get my unique IP address, and Google actually gets its own IP address. And so when I type in www.google.com, there's actually a domain DNS server that figures out, okay, Carrie wants to go to google.com. So let me translate that kind of like a phone book. Like you might look somebody up in the phone book, and then when it give you their phone number, it looks up Google in its phone book and finds out what the IP address is and converts my request from this Google request all the way to what the IP address is. Now this phone book here, this lookup system is called the Domain Name System, DNS. And there's special servers called DNS servers whose only job it is to function as a phone book. And so if I want to send this request out to get Google, I might have to go through this DNS server, which is going to be like, oh, you want to go to Google? Then you really want to go to this address, or you want to call this number, or you want to go to this IP address, and then it would take me to Google. All right, so this is one of the foundational protocols that the internet is built on. So we've learned a couple. The IP protocol, which is the establishment of IP addresses. The domain name system, which is the translation of website URLs. Or let me write this one out. So basically what the domain name system does is it DNS converts URLs, which are much easier to remember, like google.com, to IP addresses. It would be so annoying if we had to actually type these in, right, when we want to go to a website. You guys are much of a different generation than I am, but I remember that prior to cell phones, I'd have to remember all my friends' phone numbers so that I could call them. Nowadays, you just type in their name and your phone looks up and calls them, or you just press a button on their name and it calls them, so it's kind of a similar system. So this is what the DNS does. All right, now there is actually a really dangerous kind of attack that can be done to exploit this. So let's draw our I'm going to draw a picture again. So we've got our computer. It connects by Wi-Fi maybe, so radio waves, to my router. My router turns that into a copper cable. I'm looking for, let's say, similarly, I'm looking for google.com. It connects me to the DNS server. The DNS server is all like, oh yeah, you wanted Google. Well, really, that's the IP address 200.200.135.049, and I'm just making that number up. That's not actually Google's IP address, I don't think. And then it goes through that network of routers where it finds a path through this, and then eventually connects to Google's server. Because it goes to the right IP address, which was 200.200.135.049. All right, so a DNS spoofing attack is actually a really remarkable hack. So you can imagine hacking Google would be really hard, right? They are such a robust, famous company. So instead of trying to hack Google, what a DNS spoofing attack does is a hacker actually tries to hack the DNS computer right here. And if you can hack into the DNS computer, what you can do is you can actually go into that phone book and you can change the entry for Google. So change the IP address for Google to a hacked website. or a hacked website. And this is so dangerous, right? Because I could design a website that looks exactly like Google, and maybe I ask you to log into your Google account, but you're not actually on Google. Because I changed the IP address, I might change in the phone book here so that Google doesn't send you to the right address. Instead, it sends you to 100.100.100.100. I'm just making that number up. And maybe that's actually my server, the hacker server. And so by redirecting the traffic, you can think that you're actually on Google because you typed in Google, but because I changed in the phone book the location that it sends you to, it will actually send you, oh, I'm looking for Google. Okay, wrong entry in the phone book, 100, 100, 100. It's going to send you here instead of to the actual Google. And then if I'm smart, I'll make this website look like a Google site and ask you to log in. And then when you try to log in, I'll have your password because you logged in on my hacked server computer. So that is amazing. That's crazy. So this happens relatively frequently, and there are things that you can do to protect yourself. If you look in the URL bar of your computer, you can often see a locked little lock here. And what that little lock means is it guarantees a couple of things. If you click on it, it will guarantee that your connection is secure, or it will tell you whether it's secure or not. But it also will let you see something called the certificate. And so websites and their IP addresses actually get authenticated via the internet. And so you can actually see that it has the correct certificate for Google. And if you're on the hacked site, you would see that it doesn't have the correct certificate for Google. So this is perhaps interesting to explore. I recommend clicking on this little lock at google.com or whatever you'd like to click on and seeing what the certificate looks like for that website. And that's a guarantee that that website is the correct website. All right, so the DNS system is not necessarily used for hacking. This is, just like we said before, one of the foundational systems, protocols, that's used to build the internet. And so the way that you can construct this these IP addresses basically is these are also hierarchical. So if you go to a website, www.images.google.com, this basically means the World Wide Web, so we're going to ignore this. So if you go to images.google.com, it's a little bit backwards. This actually goes backwards in its hierarchy. So what you can tell here is this is a company, and it's located in the US because .com is the US company. The company is Google, so that would be the domain is Google. And then the subdomain of this would be the images subdomain. And so you have a guarantee when you're on this website, because images is the subdomain here, this is a part of Google's site. So if we were to reverse the order here and do something like google.images.com, this would actually be very dangerous because this would not be a Google site. This would be the Google subdomain of the images site. And that images site may have nothing to do with Google. There's no guarantee that it's related because it's not part of the Google domain. So this is part of the images domain. And Google does not own this site. Now they may have bought this site as well because people had made this error so many times, but there's no guarantee that Google owns this site based on the construction of its IP or of its URL. All right, so let's think about how this could be connected to malicious use of the internet. Hold on one second. Let me just make sure I said everything I wanted to say. Oh, there's one important distinction that you might think about too. A lot of the time, websites will have things like this, www.google.com/images. And once you start having these slashes, that's not necessarily connected to the domain, subdomain, hierarchical order here. This is still going to be part of Google, because if you look at the main piece of the URL, it's part of the Google domain. So what we're talking about here is not slashes, but these dots. All right, so let's review that really quickly in a multiple choice question that would be the style of your AP exam, but you're not taking that because it's canceled for Corona. So according to the domain name system, DNS, which of the following is a subdomain of example.com? See if you can figure this one out on your own. All right, so it's actually the first one, because about is the subdomain, and example.com is the main domain, and it has to go in this order. Example.co.uk, .org, and .org here, these are different domains. All right, so this actually is really connected to an idea called a phishing attack. So many of us have been targeted by phishing attacks. And if you want to see if you're targeted by a phishing attack, probably an easy way to do it is go into the spam folder in your email. And a lot of time when you go into that spam folder, you can see emails that look pretty authentic. Like you might get an email from UPS, and it's like, from UPS, subject, tracking for package, and then maybe in that email it's got a link, and that link is something like www.ups.tracking.com, or tracking.com or something. I don't know exactly what the URL would be. And you're like, oh yeah, like I must have ordered a package. Let me click the link. And sometimes this is an actual email from UPS and you're actually tracking your package. But other times this is a phishing attack where somebody who's not UPS has pretended to be UPS. And I showed a couple of you guys in class some months ago that I could send email addresses where it looked like I was UPS. So you can send emails where it looks like it's coming from UPS or something that looks like UPS. You can put whatever you want as the subject name. And then if you create an authentic looking link here and it goes through all of the spam filters and things like that, it can look like a correct link. So this link may actually be a virus. So part of the reason why they call this a phishing attack is it's almost like you're fishing and you're putting bait out there. This is like your baits. And then you want them to click this bait so that something happens that's not so good for them. All right, so in particular, I chose this link because it illustrates something about the domain name system. You might think, oh yeah, I see UPS here, it's super safe. But this isn't actually part of the UPS domain. This is a subdomain, so there's no guarantee that this address is connected to UPS. This is actually connected to the tracking.com domain. And that domain may be taken already. That might be a perfectly fine domain. But maybe I can come up with a similar domain that looks somewhat authentic. So like maybe ups.trackingservices.com or ups.packageservices.com. And then I bought the packageservices.com or whatever it is. And it looks like that. Now, a lot of the time, this website might ask you to log in with an email and a password. So now it gets information about you. It gets your email. It gets your password. It can log into your actual UPS account. It can redirect packages, perhaps. They can study what you were trying to order and then send you advertisements for those things. It's pretty wild. They might take over your email address and make it look like you were sending emails to all of your friends. So a phishing attack is basically when you get a false link and it's masked to look real and you click it anyway. All right. Oh no. Okay, so it looks like the last page here didn't get saved, but I did save it on my computer. So there is one more page here. So let's do these questions. So question 6 is, what is a computer virus? And a computer virus is a term that's based on a biological virus, right? A virus takes over a computer system or a human system in such a way that it can spread from computer to computer. Now, you might be wondering, like, what are some of the uses of this? Like, why would you want to spread a virus from computer to computer? And the uses are myriad here, right? Like, you may just be doing this for fun. You might just want to see how many computers can you get your program on. You may be doing it because you want to create something called a botnet, which we're going to talk about in the next question. You might want to spread your computer virus from computer to computer because you want to track users. Maybe you want to spread your virus from computer to computer so that you can find secret information about those users and blackmail them. Maybe you want to spread your virus from computer to computer so that you can shut down all of those computers. You can shut down a network. An interesting example of a computer virus, though, is there's actually, our government actually has a cyber war department. And we actually became increasingly alarmed about Iran's ability to create a nuclear weapon. And when we found out that Iran was working towards a nuclear weapon, they had a set of computers attached to centrifuges, which are important in refining nuclear material. And we actually, we've never officially admitted to it, but it's pretty well known that the US created a computer virus that actually spread from computer to computer and infected the centrifuge computers, and then changed the way that the centrifuges were manipulating the nuclear materials so that they would break down, and it would destroy all the research that the Iranians were doing on and all the progress that they're making on refining their nuclear capabilities. So that's actually in Darknet Diaries if you want to listen to more about that, but cyber war could be another example. All right, so let's talk a bit about botnets. So botnets are pretty interesting, and they tie together a couple of things that we've been talking about. So it stands for a bot network. So let's say I am a malicious hacker, and I want to shut down, let's say I want to shut down Corey's Pizza because their website has been doing so good, and Carrie's Pizza, my goal is to shut down Corey's Pizza so Carrie's Pizza gets business. Now, we talked a bit about this before. I could try to do something called a DDoS attack, where I send so many requests to Corey's Pizza's server, and I'm like, hey, yo, get me the menu. Hey, yo, get me the menu. Hey, yo, get me the menu. And you can tell that, just like that example, is going to be overwhelming as a human, but it could also overwhelm the computer server. Now, the problem here is that I might not have enough computers to send all those requests. So even if I get my computer to send as many requests as I possibly can by using some Python program or something to keep asking for Corey's Pizza's website, it might not be enough. So what I could do is I could actually create a virus. So I could create a virus, I could send an email to thousands of people. Maybe I have a list of email addresses because I was able to hack into, I don't know, like JCrew's user database and see all the email addresses there. So I send all of those people an email address. It looks something like update your order, update JCrew order or something. They click the link because they want to update their JCrew order. They're like confused. Did I place an order? In reality, that link downloads a virus. that virus, maybe it has a capability where it spreads from computer to computer, so it sends that virus to everybody on their contact list. Virus spreads. And then what happens is there might be a special feature of that virus where when I press a button on my keyboard, it causes all of those computers to try to access Corey's Pizza over and over. And by doing this, instead of just having my computer do it, I've got actually a robot network, a set of computers that I am secretly controlling in order to do a DDoS attack on Corey's Pizza. And by controlling those thousands of computers, I may be able to actually shut down the server, depending on the capabilities and resilience of that server. So I think this is a nice example because it ties together a couple of things. It ties together this idea of viruses that spread from computer to computer. We're sending an email, so that's going to be a phishing email. It looks real, right? Maybe it's something along the lines of like www.jcrew.orderupdates.com or something. So now we're doing a DNS, or we're doing sorry, not a DNS spoofing attack. Maybe we're doing an attack based on the DNS system, where this is actually part of the order updates domain, which looks like it's part of jcrew, but it's not really. So they're really logging into my fake website to download a virus. We're just going to spread that virus to their other computers, and then we're doing a DDoS attack to Corey's Pizza to shut them down. All right, cool. I'm glad that we made up that whole fake hack. It's awesome. And then finally, let's talk about a real hack. So this real hack is an example of something called ransomware. And I think it also ties together some of the important principles that we talked about. So what is the WannaCry attack? All right, so ransomware, to start off, is kind of exactly what it sounds like. A virus that locks you out of your computer unless you pay a ransom. And this is similar to blackmail, where maybe somebody would hack into your computer and get access to your Google search history or your photos or some information that you want to keep private, or your credit card number, or a disease that you had that might undermine something. I don't know. They get access to a secret piece of information about you based on your computer. And then they say, hey, unless you give me money, I'm going to share this with your contact list or something like that. Ransomware, on the other hand, is going to lock you out of your computer. And you're going to make you pay a ransom in order to get back into your computer. So this could be very scary, I imagine. But in particular, this is very scary in this particular attack called the WannaCry attack. So the WannaCry attack is a hack from 2017. And in this attack, the target of this attack was actually hospitals. Or actually, it's not necessarily that they were the target, but hospitals were very vulnerable to this attack. And hospitals are particularly vulnerable for a couple of reasons. Computers in a hospital are responsible for... hospital computers are responsible for keeping patients alive. So, if you're hooked up to a device like a respirator, there's a computer inside of that respirator that keeps that respirator pumping, that measures your vital signs. If that computer gets shut down, that patient will die. So these are valuable computers. Furthermore, people don't update hospital computers. So you may get updates on your computer to say, hey, there's an update your operating system. And you might be like, I don't want to do it because then I can't use my computer for like 5 minutes. In a hospital, you really can't update computers as readily because those computers are hooked up to patients and responsible for keeping them alive. So hospital computers are often not fully up to date. So if you ever get an update on your computer or your phone, I strongly recommend that you pause and you do the update because oftentimes it's a security fix. Hospital computers have a hard time doing this because they're responsible for keeping patients alive, so how do you restart them or update them? Kind of hard to do. So what the WannaCry attack was it was actually a ransomware attack that was launched. And it locked hospitals out of these computers unless they paid a Bitcoin ransom. And the Bitcoin ransom has a couple of benefits, right? It is a digital currency that's not regulated, so it's harder to track or things like that once the ransom has been paid, and it's more anonymous. The belief is that the WannaCry attack was actually launched by North Korea, but many times people don't actually own up to these hacks because it's not advantageous to say, hey, we tried to hack you. So it's suspected that this was a North Korean attack. So I'd recommend that you read more about the WannaCry attack. And if this field is interesting to you, I recommend that you check out this podcast, The Darknet Diaries, because it's got a bunch of great stories, some of the ones that we've talked about today. And if you're really interested in this field, then I recommend that you major in cybersecurity, because there's a way that you can basically hack for a living without doing it illegally, which is to get a job as a computer security specialist where you get hired to try to hack into systems to find vulnerabilities before actual hackers do. I don't recommend that you guys learn how to hack computers or do any of these attacks if you're not a computer security specialist, because hacking is a federal crime and you may find yourself in trouble with the FBI. We're going to talk more about how people protect themselves from these types of attacks in the next lesson, but I hope you have an idea now of some of the ways that computers can be co-opted or maliciously used. And in particular, you might be thinking about, how does that connect to my Apple Watch? Or how does that connect to my iPhone? Or how does that connect to whatever device you're thinking of researching? All right, guys, have a good rest of your day.